Okay, guys, so let's start it. So I'm gonna share my screen first. Guys, so please so listen to this case study very carefully. If you have any questions, any doubts, you can stop me there and please ask questions because a lot of concepts are not familiar to you. Because I just want to show you like how we can use in real world, how we can use all this in real world. So there are few concepts we haven't covered so far for the data analysis. Okay, but whatever the concepts gonna come inside this case study, I'm gonna explain you step by step. But if you don't understand anything, you can stop me there and you can ask questions about it. Okay, guys, I hope all the instructions are clear to everybody, guys. Okay, so let's start it. Okay, guys, so let's suppose, guys, I'm gonna say case study using Python or using like Python libraries. Okay, guys, so in this, I'm gonna use multiple libraries now. Libraries, guys, few students are like new to this class. Library means there are in Python there are so many different libraries, and by using those libraries, we create project, we create models, we create models. Like suppose if we talk about insurance, or if you talk about House Sigma, if you talk about Zolo, guys, have you heard about these platforms? Have you heard about House Sigma? Have you heard about Zolo? Like guys, all of you are live in Toronto, right? You guys live in Toronto, right? So Zolo House Sigma is the platform we use to find homes for the renting, for the buying houses. So these are the platforms which we use, and these platforms also use machine learning to estimate what should be the price of this house. Because suppose you are the house owner and you want to sell this house for like let's say $1 million, but the actual cost of the house is not $1 million. Actual cost of the house is something less or something more. But how you get to know, how you can standardize your house price based on the market, based on the previous houses like you, based on all this data, the model will estimate your house should be this much amount. So that's how we use machine learning. We use data analytics to estimate something. Suppose if you go for an insurance company, if you want to buy insurance, what you do? You call insurance company, you give your inputs like my age is this, my car is this, my location is this, my experience is this, how that the tickets like the offenses I already have is this. So you give all your input details, right? You give all your input details. Based on your input details, their model, insurance company model, give you some kind of estimation. How they get to know that? How they get to know that we're gonna charge this much amount from you based on their previous data, based on their previous records. Okay, so in a similar manner, today we're gonna use one data set called California housing data set. It's not a new data set, it's a quite old data set, quite popular data set. And in this data set, there are around 20,000 records, 20,000 readings in this data set. By using this data set, we're gonna predict the pattern. We're gonna find the pattern inside this California housing market. We're gonna find the pattern in California housing market, and based on that pattern, we're gonna find what should be the future house. What should be the price of the future house? Suppose, like we have this historical data. Now, suppose now you are the new seller or new buyer in the California, and you want to see how much my house worth, how much my house worth. So what you gonna do? You're gonna put your house details, input features. You're gonna put your input features in that model, and based on your input features, model will predict the house price should be this. And whether that model is good or bad, I'm gonna show you how you get to know that model is good or bad. Okay, so in this case study, There are so many things we haven't covered so far because it's a big course. I cannot cover in 3 weeks. So what we're gonna do, I'm gonna show you the important things in this case study, and I will discuss those things. If you don't understand anything, I will tell you today I'm gonna answer those questions or not. Okay. So please stay careful and ask questions and stop me there. Don't wait for the later on part. Just ask questions whenever you don't understand anything. Okay, guys. So let's start it. First of all, I'm gonna import some libraries from import, and you, if you want, you can practice with me. Okay. Import pandas as pd, import numpy as np, import, I'm going to import some libraries, cborn as sns, import from matplot, from matplotlib dot py plot, as plt. Oh, sorry, not from, import. And that's it. So for now, I'm going to use these libraries. Okay. So I'm going to import these libraries. So guys, any questions why I'm importing these libraries? Any questions regarding this? No questions. I hope everybody knows why I'm importing libraries. Okay. So next thing now. Now, first of all, import dataset. So California housing dataset is already present inside Python. Okay. So what I'm gonna do, I'm gonna say California. What I'm gonna do from sklearn. Now sklearn is very important library, guys. We haven't covered this library, but it's a very important library. Inside this library, majority of models, machine learning models are present inside this library. Okay. So in this library, I'm going to import the dataset. From this library, I'm going to import the dataset from sklearn dot datasets, import or import fetch. Now we have all these data here. Fetch 20 news groups, 20 news groups vectors, California housing, uh, COV type, LFW pairs, LFW people, fetch Olivetti faces, fetch open ML, fetch RC1. So we have lot of data here. Okay, fetch species distribution, fetch iris dataset. So there are so many datasets are already present inside sklearn. Okay, so out of those datasets, I'm going to use this California housing. Okay, so fetch California housing dataset. Okay, so this is my data is now loaded here. If I open this, so my data is now here. Now how I'm going to do this? Now look at this. I'm going to say California, or cal. You can use any variable name here. It's up to you. Okay, cal is equal to fetch. I'm going to copy this because this is a very big name. I want to use smaller name. Okay, so that's why I'm using cal, and I'm using the smaller name. I'm creating an object. If you are familiar with computer language, I'm creating an object for this class. Okay, creating an object for this class. This is a computer language. But in a simple language, you can say I'm creating a variable, because this is a very big variable name. So I'm creating a variable here. It's in computer language we call it object. I'm creating object here. Okay. Now inside this cal, there are so many things. Inside this cal, if I open this cal, look at this. Look at this, guys. So guys, first of all, what is the type of cal? Deep, answer it. What is the type of cal? Mute. Deep, you are on mute. Can you unmute, please?
Dictionary type?
Yeah, very good. It's a dictionary type. How? Priyanka, why it's dictionary type? Please unmute yourself. Guys, fast. We don't have time. It's a
Sorry, I don't
very
have
big
idea.
case study. Yeah, go ahead.
Sorry, I don't have idea.
You don't have any idea why it's dictionary type.
Yeah, actually, I joined late.
No, but you joined, I think, from the first class, I guess.
Yeah,
Right? But why it's dictionary type? Can you see this curly bracket? So whenever there is a curly bracket, it's called dictionary type. You remember?
yeah.
Okay. So guys, okay, Jamin, can you unmute yourself? Guys, please,
Yes.
everybody unmute yourself. If there is a disturbance behind you, then mute yourself. Otherwise, you can unmute yourself if there is no disturbance behind you. Jamin, why? How many different keys we have in this? Can you tell me any three?
Data,
Data
target,
is one of the
frame,
key. Yeah. Any other? And any other two?
data, target, frame, target
Very
names.
good, Jamin. Yeah, these all are the keys. Okay. Now in this California, we have lot of things. We have lot of keys. This is the first key is data. Second key is target. Third key is frame. Fourth key is target names. Fifth key is feature names. Sixth key is description. Okay. If you want to see the description of this data, you can see D. You can see description and you can read about this data set. You can read about this data set. Okay. You can read about this data set and you can think about what is this data set. If you want to see it fully, you can say print California description and you will see the whole description about this data set. Now let me uh, discuss about this data set. So in this data set, we have this is data set called California housing data. In this data set, we have 20,000 records, 20,640 records. In this data set, we have 8 input features. 8 input feature means 8 columns. Okay, this data set have 8 input features, and based on those 8 input features, we need to find some target. And what is the target here? And there are no missing value. There are no missing value in this data set. Sometimes in your data set, there are going to be missing values. And when there are missing values, we need to correct those. We need to fill those. We need to delete those. Depends on the question to question. Okay. But there are no missing values in this data set. And the target variable, the target we want to predict, the target I want to analyze is the median housing value. I want to analyze in this particular area, in this particular, let's say, in this particular colony of California, or in this particular block of California, what should be the median housing value? Guys, everybody know what is median, first of all? Guys, everybody knows what is median? Yes or no, guys? So median is the middle
Average.
income. Let's suppose, so let me explain a little bit. So what is median here? So suppose we have house in this block. This is the whole block. In this house, this is the house 1, house 2, house 3, house 4, house 5, house 6, house 7. This is the one block. There can be another block like this in California. There can be another block in this, like in let's suppose these blocks in Los Angeles. So Los Angeles is a city in California, guys, if you know that. So there is, let's suppose there is these blocks, there is another blocks, house 1, house 2, house 3, house 4, house 1, house 2, house 3, house 4, another block, house 1, house 2, house 3, house 4, house 5. And this, all the blocks are present in, let's suppose, San Francisco. San Francisco is another city in California. Let's talk about Toronto. Let's forget about California. Let's talk about Toronto. Inside Toronto, inside GTA, there are so many different cities. Cities means like Etobicoke, Brampton, Mississauga, or Scarborough, or let's say in North
Average.
York. So different cities have different blocks. In now, what is the median housing value? So what is the median housing? Suppose this house price is 1.1 million. This house price is 2 million. This house price is 800K. This house price is, let's suppose, 1.5 million. This house price is, let's suppose, 1.3 million. This house price is, let's suppose, 900K. This house price is, let's suppose, 1 million. Now, how to calculate median, guys? Anybody? How to calculate median?
First, arrange from smaller number to bigger
Very
number,
good.
and then
So
see.
first we need to sort them in ascending order. Mahek, first we need to sort them in ascending order. So in this particular thing, so need to sort the 800K, 900K, 1 million, 1.1 million, 1.3 million, and 1.5 million. I'm gonna go up, guys, and 2 million. Okay, so this is my sorting ascending order. So to calculate anything for the median value, we need to sort them in ascending order, and we need to find the middle value. So what is the middle value? Total number of values are like 1, 2, 3, 4, 5, 6, 7. Total number of values are 7. So middle value is 4. So 1.1 million values is median in this case. This is the median value. Guys, you got it or not? Say yes or no, please.
Yes.
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 Okay. So this is called median value. So in this particular question, let me clear everything. In this particular question, so a block group, look at the description of this dataset. This dataset was derived from 1990 US census using 1 row per census. Block group. A block group is the smallest geographical unit for which the US Census Bureau publishes sample data. A block group typically has a population of 600 to 3,000 people. So let's suppose in one block there are going to be let's suppose 4 people lives in one house on average. So let's suppose in one block the houses are going to be 150 to 750 houses. Let's suppose. Okay, 150 to 750 houses. So these are the, look at this. These are the 20,000 blocks. These are the 20,640 blocks. Okay, 20,640 blocks in California. And we need to calculate the median housing value in each block. Guys, do you understand the data set or not? First of all, there are like, if I open this data set, let me open this data set. So guys, data set is DF is equal to PD. I want to convert this into data frame first. PD dot data frame. PD dot data frame. Okay. And PD dot data frame, and I want to give cal dot data is equal to. Let me clear this. PD dot data frame data is equal to. This is like California dot data. Sorry, cal dot data. So this is my data, and I need to give the column names as well. So in this, if I give this, there is no. Let me see. Okay, it should be pad. That's why I'm getting error. So PD.data frame California.data. If I don't give, if I do this, if I run this, what will happen, guys? Look at this. There are no column names here. But I need to give the column names as well. So this is my data set, guys. Okay, this is my data set. But I need to give column names here. Column names are not present here. So how to give column names? I know if I open this, look at this. These are my input features. These are my column names. This is my median income is my first column name. Housing age is my next column name. Age room is my next column name. So these are my column names. So I'm going to say California.data, comma, columns is equal to what? Guys, columns equal to what? Anybody? Columns is equal to what? Columns is equal to, guys,
Attribute
data
information.
is equal to California.data. Columns is equal to California dot features. Is it or not? Feature names, sorry, not features, feature names. If I open this, let me show you California again. If I open this, look at this. So this key. This particular key has all these values: median income, housing age rooms, average bedrooms, average population, average occupation, occupancy, latitude, longitude, right? So that's why for the columns, I'm using this key. I'm using this feature names key because these are my columns. All of my columns are here. Guys, questions? If anybody doesn't understand, questions, please. Priyanka, Deep, Priyanka, you are looking blank. Any questions?
But this date, like here you used this feature name. So how to recognize that data is used to do this to grab the data?
So look at this inside. If I open this, so first of all, do you understand this part or not? First of all, do you understand
No,
this
actually,
part or not?
I thought the data is keyword to grab the data.
Yeah. So like, look at this. This is the data, right? This
Yeah.
California is my variable name. California is my dictionary name. So let's suppose, let me show you first. So it's a dictionary property. I'm using dictionary property here. California is my dictionary. Okay. If I say type of California, I know it's confusing. You need to practice that. Type of cal, it's a bunch. It's a dictionary. Okay. Now, if I want to say California dot keys, California dot keys. Look at the California dot keys. So how many keys we have in this California?
Yeah.
Data, target, frame, target names, feature names, description. These are my keys. Okay. So the first California dot data is my data. Like all the numerical continuous data is present inside data. Inside target is the values for my target data. Do you understand or not? What I'm trying to say here. Look at this. If I say California dot data only, it will give me only the data. Look at this array. Array isn't a two-dimensional array. Two-dimensional array is called matrix. You remember?
Yeah.
In the NumPy, we have done this. Look at this. This is two-dimensional array. Okay. So this is my data. If I say California dot California dot target. Now look at this target now. California dot target. Look at this one-dimensional array. Only one column. All the continuous values. Okay. If I said California dot feature names. Feature names. If I do this, look at this. This is my values for the feature names. If I say California dot target names, this is, oh sorry, it's target names. So this is my target name, only one column, because target can be only one column. So do you understand what I'm trying to do here?
Yeah.
Still confused.
No, got it now.
So here my data, this is my data. California dot data is my data, and California dot columns is equal to California dot feature names. Feature names. Now if I run this again, look at this now. So data has 7 columns, 1, 2, 3, 4, 5, 6, 7, sorry, 8 columns, and there are 8 feature names. So that's why I got it. Okay. Any questions until here, guys? Any questions until here? I know it's complicated. You need to practice. There are so many steps we haven't covered, like how we do this, how we create data frame. We haven't covered those because it's going to take a lot of time. I just want to show you actual case study because today is the last class. Okay. So it's clear, guys? This part is clear or not? Now I have this. Now my data is clear here. And let's suppose I want to also add in this data frame. In this data frame, I have features. I have input features. Input features are those features which are given by the user, which are given by the customer, which are given by the client. Output feature is that feature which gonna give by the model, your model. Always remember, in any model, there are input features. Input features can be multiple. Output feature is only the one. Always remember that. Even for insurance company, for second-hand car, even for the second-hand car, like Kijiji, right? Kijiji, marketplace. Over there, you have to provide input features of your car. What is your model of your car? What is the brand of your car? What is the mileage on your car? Like a different thing. Is it first hand, second hand, third hand? You give multiple input features. And your model, Kijiji model, Facebook marketplace model, Google car 24. There's a car 24 model. They will provide you the estimate price of your car. How they calculate that? By using this kind of machine learning model. How they do that? Okay. Any questions so far, guys? So similarly, what we're gonna do? I have this data set, 20,000 records. I have this data set. Based on my past data, my model will learn from my past data. My model will learn from my past data. If there is any future input features, suppose this is my model. In this, I have both input features, and I'm also going to add price as well. So what I'm going to do, so inside this df, what I'm going to do, I'm going to say df, I'm going to add one more column. Inside this df, I'm going to add one more column. That column is output variable. That column is output variable, and I'm going to add it. I'm going to say, let's say price, or you can say median housing value. It's up to you. You can give any column target name. Okay, it's up to you. Inside the data set, the target name they used, they use this target name. Where is the target name? There's a target name. I'm not able to see the target name. Okay, let me take out the target name from here. I'm not able to see the target name here. So I'm going to say California dot target name. So this is the target name. Dot target. So this is the target name dataset has used. You can use this target name, or you can use some other name. I'm going to use price. Price is like more easy to understand. Or you can use this. It's up to you. Okay, guys, is it clear? So what I'm going to do, these are the input features, and these are the target names. So price is equal to cal dot target.
We cannot hear you.
So guys, this price is in thousands. Okay, this price is in thousand. So look at this. Look at this. The target variable is the median housing value for California districts expressed in hundred of thousand. So this means 452,600 dollars. This means $358,500. Guys, give me 1 second. Hello. Yeah, go ahead. Okay, guys. So guys, this data set is clear to everybody or not? Please ask your questions. Is it clear to everybody? Priyanka, Deep, Jamin, Mahek, is it clear to everybody? Tanvi, Amarjot. Guys, say yes or no, please. Okay, guys. So look at this. Now this data set is ready. Now I can start my analysis. Okay. First of all, any data analysis, we draw some graphs. We visualize the data set first. Okay. We visualize the data set. We try to find what is the pattern inside this data set. Okay. For any analysis, no, before doing the graphical analysis, we clean the data set first. But in this data set, my data set is already clean. But how to check your data set is clean or not? So I'm going to show you some tricks. How to check your data set is clean or not? First of all, I'm going to do the descriptive analytics. Guys, note down how to do the descriptive analytics inside Python. Descriptive. So guys, you know what is descriptive analytics, first of all. What is Deep? What is descriptive analytics? Any idea? Guys, fast. Deep, descriptive analytics. What is descriptive analytics?
It requires all kind of detail, and from those
Like,
details,
can you give me some parameters we calculate for descriptive analytics?
we can go for insurance, I believe.
No, inside this we don't have any insurance. Like, just okay.
Oh,
leave it.
California. Yeah, housing
Okay.
market.
So guys, first of all, what is descriptive analytics? Descriptive analytics means to calculate the basic parameters like average of each column, to calculate average of each column, median of each column, to calculate 25 percentile of each column, 50th percentile of each column, 100 percentile of each column, to calculate what? To calculate standard deviation of each column. Guys, you know what is standard deviation? I'm assuming everybody's from maths background, right? So in data analytics, these terminologies are very important. So how to do descriptive analytics? Descriptive analytics means, guys, descriptive analytics means whatever is already is in front of you. Data is in front of you, and you need to find some parameters out of data. Like what is the average housing value? What is the average price? What is the average number of bedrooms in the California housing? What is the average number of bathrooms in California housing? What is the average house age in the California housing? What is the average population in each of the block? What is the average occupancy in California? So you will get all these details. Descriptive analytics means how to do that. df dot describe, and this will give you all the descriptive analytics. Like count means the number of values in each column. Okay, the number of values in each column. So every column has equal number of values. That shows there are no missing values in each of the column. Look at all the columns. All the columns has equal values. That shows there are no missing values in each of the column. Guys, this part is clear. The second thing, mean of each column. So mean of median income. So mean of this is also in 1,000, guys. So mean of median income is 3 point like what is this? 3870. So 38,706.71. So this is the mean median income. $38,000, 706.71. Okay. So median income is also in thousands. And this is the mean of housing age. So in California, average age of housing age is 28 years. Okay. So the number of bedrooms in California, average number of bedrooms in California is 5 bedrooms. 5.4 is, let's say, 5 something. Average number of average number of rooms is 5, and average number of bedroom is 2, approximately 1. Because some are condos, some are houses, so average is 1. Population in each block. In California, the population, average population in each block is 1425. Guys, do you understand now? Standard, guys, do you know what is standard deviation? Anybody who doesn't know what is standard deviation? Anybody who doesn't know about standard deviation? So guys, standard deviation is the variation from mean. Standard deviation is the variation from mean. So let's suppose average population is, let's suppose, so let's suppose average, okay. Guys, because standard deviation is very important parameter to understand. What is standard deviation, guys? So let's suppose average salary, let's suppose you guys all are working and average salary of you guys is, let's suppose, $5,000. Average salary is $5,000. Now let's suppose X1, let's suppose some students are, some of you guys are making $3,500. Some of you are making 4,000. Someone is making 5,500. Someone is making 6,000. Someone is making 5,000. Let's suppose now these are the 5 members. These are the 5 members and average salary. Let's calculate the average here. 11,000, 11,000, 6,000, 18,000, 17,000, 20,000, 24,000. 24,000 divided by 5. So what is the average, guys?
4,800.
4,800. So average, let's suppose average salary is 4,800. Okay, so this is average salary. So now what is standard deviation, guys? So if average is 4,800, how this person is varying from mean? How this person is varying from mean? So how to calculate the standard deviation? So calculate the standard deviation, guys. Let me write the formula here.
Square root of.
Standard deviation means, so calculate standard deviation means, so x minus x bar whole square divided by n square root. So this is the formula to calculate standard deviation. So x, what is x here? X, let's, instead of x, I'm going to say xi. Xi minus x bar. So if I say this person, how this x1 is varying from mean. So how I'm going to calculate? I'm going to calculate 3,500 minus 5,000 or 4,800. Let's say 5,000, guys. It's going to be easy for me. 5,000 divided by 5. So it should be what? 1,500 divided by 5. It should be what? 300 square root. So 300 square root is what? It should be 17.32. Sorry, 1.73 under root 3 into 10. 17.32. So it's 17.32. So it's 17.32.
No, you forget to square the 1,500.
Yeah, very good. Yeah, 1,500 square. Yeah, 1,500 square means okay, 225.
225,000.
5 and 4 zeros.
225 into
40.
100. Okay.
Into 1,000.
Into 10,000.
Yeah.
I'm going to do
10,000.
like this. Upon 5. So this is what? This is what? This is 125. No, this is what? 45.
45.
So 45. So it's 100. What is the 45 square root, guys? 45 square root is
Answer for the square root is 670.8.
6.7.
670.
6.7, let's suppose.
6.78.
So it's,
yeah.
So it's what is 670?
Yeah,
It's
670.
670.
Yeah.
So standard deviation is 670. Standard deviation is 670 here. So now this 3,500, how this 3,500 varying from 4,800? So this 3,500 is varying from 4,800, like 2 standard deviation. 2 standard deviation approximately. Guys, I know this is confusing. Look at this. Average is 4,800. Average is 4,800, or let's say 5,000. Average is 5,000. Now this 3,500 varying from 5,000 is what? Approximately more than 2 standard deviation, because 1 standard deviation is 670. Two standard deviation is what? 2 standard deviation is what? 1440. Sorry, 1340. 2 standard deviation is 1340, guys.
Yeah.
So 3500 varying from 4800 or 5000 is 2 standard deviation approximately. So this, why we are calculating this thing, this will tell you every response, how every response is varying from your mean. Standard deviation is variation from mean. Okay, guys, if you go for the whole data science class, then we're gonna do statistics course over there. So inside statistics course, we're gonna discuss all these things: standard deviation, variance, interquartile range, all of those things. Okay, so data for understanding data analytics, these things are also very important. Okay, but we don't have that much time to cover all those concepts. But I just want to explain you that standard deviation means variation from mean. That's it. Variation from mean. That is the definition of standard deviation. I hope it's clear. So let me clear everything. So this is, guys, descriptive analytics. Okay, this is my descriptive analytics. Now inside this descriptive analytics, now I'm gonna, there is another way to check, is there any missing values inside this data set? So this is the way, df.info. So info will tell you there is all the columns are non-null values. 20,000 values are non-null. Okay, if there is any null value, you will get to know that there are missing values in this particular column or that column. Okay, there is another way to check null values. This is the way, df dot is null dot sum. It will calculate the number of missing values in each column. So in this case, there are no missing values. If there are missing values, it will show you number of missing values in this column, number of missing values in this column, number of missing values in this column. It will show you that. Okay. Then the next part. So this is how we do the feature engineering. Feature engineering means cleaning the data. So by these ways, we check whether there is anything we want to clean the data first. If my data is clean, if my data is good, if there is no discrepancy in my data, then we can do the graphical analysis of my data set. Okay, once I make sure my data is clean, then we do the graphical analysis of my data. How? Question, go ahead.
If example, if we have your null value, then in that case, how do we clean that?
How do we clean that? That's like a big task. But yeah, there are so many ways. One way is to delete the whole record. Suppose let's suppose in this, suppose this particular value is null value. This particular value, suppose is null value. This is a null value. Okay, there is nothing inside this value. So what we can do first, the most basic way is to delete the whole record. Delete the whole record. How to delete the whole record? There are so many ways. I'm going to show you. Okay. Second way is to put something inside this value. You can fill anything inside this value. Usually there are three techniques to fill inside this value. Either we're going to fill mean of this whole column. Either we're going to fill the mean value inside this mean value. That is the first scenario, scenario 1. Second scenario is either the fill median value, that is the scenario 2. Or third scenario is either the fill the mod value. But mod value we only fill inside the category data. If the data set is category data, if the column is a category data, then we use mod. If the data is look at this. This is a numerical data. This is a numerical data. Then we don't use mod. Either we're going to use median, either we're going to use a mean. or we're going to delete the record. So we have three options. Depend on data to data, depend on case study to case study. We're going to decide whether I'm going to delete, whether I'm going to fill mean value, whether I'm going to fill median value. Okay, Priyanka, is it clear?
Yeah.
And how to do that? I'm going to show you, or you can Google it. It's very, it's very easy. So how to delete any column? How to delete any column? So I want to show you how to delete any column. So let's clear everything. So if you want to delete any particular record, any particular row, you can do like this: df dot drop na, and you give this, and wherever there is a null value, it's going to drop that record. Okay, wherever there is a null value, it's going to drop that record. Suppose if you have null value, if you have null value in, suppose this is a null value, this is a null value, it's going to drop the whole record. If this is a null value, it's going to drop the whole record. If this is the null value, it's going to drop the whole record. If this is the null value, it's going to drop the whole record. So wherever there is a null value, it's going to drop the whole record. Suppose in one row, two null values. This is the null value. This is the null value. It's going to again drop the whole record. So whether you have one null value inside one record means one row. Whether you have 10 null values in one row, it will delete the whole record. Because your model cannot understand null values. Your graph cannot understand null values. So we need to fix those first. Before doing any graphical analysis, before doing any model training, we need to fix null values. Okay, guys, any questions? So this is how you can delete rows. If you want to delete columns, suppose in one column, let's suppose in one column, let me clear everything first. Let's suppose in one column, suppose this column. Suppose in this column, there are so many null values, like total is 20,000 records. Out of 20,640 records, let's suppose 18,000 values, 18,500 values are null values. So what you can do with this column then? Any idea, guys? So what you can do with this column, guys? Any suggestion? Priyanka, any suggestion? What are you going to do with this column?
That column.
Huh?
We can delete that column.
The basic thing, we're going to delete that column. We're going to delete the whole column. Because out of 20,000 records, if 18,000 records are null values, it doesn't make any sense to fill those values. So I can delete the whole column. How can I delete the whole column? The same way. df.drop na, but inside here, I'm going to say x is equal to 1. Guys, you remember column is 1, row is 0. If you don't give anything, that means default is 0. Default is 0. But if you give x is equal to 1, then it means column, you are deleting column now. If you give x is equal to 0, it's up to you. Either you don't give anything, or either you can give x is equal to 0. Same thing. Because default is 0. Is it clear, guys? So the next thing, so this is how I'm going to delete my record. And if I want to fill something, so I'm going to show you if we're going to do this class sometime again. So that is a big code. But if you still want to see, I'm going to show you. So df dot fill na and df.fill na, you have to provide df whatever the column, which column I'm talking about, where I want to fill. Suppose I want to fill in median income column. So I have to give like this, median income. df median income dot, let's suppose I want to fill mean. I want to fill mean. then I have to give mean value. Okay, so this is how I'm going to fill NA values. Wherever there is a inside this median income column, if there is any missing value, I'm going to fill that missing value with mean value. If I want to fill with median value, I need to give median here. Okay, but in this case, we don't have any missing value, so it will not work. Okay. So guys, okay, so it's clear. Now next move to how we can create visualizations. Any questions so far, guys? Any questions so far? Anybody wants to ask? Guys, any questions, please? You can ask
No.
any questions you want. Okay, no questions. So let's assume, let's do the visualization now. Once my data is clean, once data is clean, then the next step is data exploration. Data exploration, that means visualization. Data exploration. Okay. So data exploration, what is data exploration, guys? So I'm going to, because this is, guys, the most important part in any case study, in any model training, is data cleaning and data exploration. That is the most time consuming. Cleaning the data and data exploration is the most time consuming. Model training is very easy. Very easy. Like you have to give like 5-6 commands, your model will train. But before going to model training, you need to understand how this model works, because we haven't covered anything about model, like what is linear regression model, what is classification model. We haven't covered any of those. Okay, but today I'm going to show you one case study for linear regression. But before going to linear regression, first I'm going to show you how to create graphs, how to do visualizations. So let's suppose I have this data set in front of me. Okay, now I want to do some visualizations. So first of all, I'm going to do SNS dot scatter plot. So guys, when to use scatter plot? First of all, when to use scatter plot, guys? You know what is scatter plot? First of all, scatter plot is dots. So when to use scatter plot? When? So guys, first of all, before doing that, let me show you a little bit about visualization. So let me explain a little bit about visualization. So visualization means, guys, there are inside visualization, there are three types of analysis, three types of visualizations. First one is univariate visualization. Second one is bivariate visualization. Third one is multivariate visualization. Variate visualization. Univariate, bivariate, multivariate. Now, what is univariate means, guys? Univariate visualization means when there is one column involved. We are analyzing only one column. We are not analyzing the relationship between one column with another column. That is called univariate visualization. Bivariate visualization means when there are involving two columns. We are checking the relationship between one column and another column. That is called bivariate visualization. Third one is multivariate visualization when there are more than two columns involved. 3, 4, 5. That is called multivariate visualization. So inside machine learning, inside data analytics, sometimes we do univariate, sometimes we do bivariate, sometimes we do multivariate. Okay. So when to use what? Because there are so many visualizations. When to use scatter plot, when to use line plot, when to use bar plot, when to use horizontal bar plot, when to use pie chart, when to use histogram, when to use KDE. So you need to understand those. We don't have that much time, but there are so many graphs. But when to use what, you need to understand those. I'm going to show you 4 or 5 graphs. and when to use those graphs. But there are so many things, so many graphs. I cannot cover all the graphs today. Okay, so SN is scatter plot. Guys, scatter plot, when to use scatter plot? Scatter plot we use for, first of all, bivariate analysis, bivariate visualization. Bivariate means two columns are involved. Bivariate visualization. And we can also use for multivariate as well. Bivariate as well as multivariate too. We can use scatter plot for multivariate as well. But we cannot use scatter plot for single variate, univariate. We can use scatter plot for bivariate and multivariate. But right now I'm going to use bivariate first, multivariate. Okay, we can use scatter plot for bivariate as well as multivariate, but right now I'm going to use for bivariate first. Okay, so what is bivariate analysis? I'm going to use two columns. So first of all, x is equal to, I'm going to say df. Let's say x is equal to, first column I'm going to, okay, guys, which visualization you want to make between what? Price and, let's say, price and
Average rooms.
Price and average rooms, or I will say house age. House age would be better.
Okay.
Price and house age. Okay. So let me see. Just give me 1 second.
So one y-axis always should be price because that is output.
It's up to you, because we are predicting price, right? So it makes sense if we take price as a y-axis.
Okay.
Yeah, but it's up to you. You can make rooms as a y-axis too, but doesn't make any sense. Okay. So guys, let's create a visualization first. Okay, so I'm going to use X as a, let's say, housing age. So housing age, guys, spelling, it's a case sensitive, so spelling is important. Okay, house age, not housing age. House age, and y-axis should be my price. Price is capital. Yeah, price is capital. P is capital. Y is price. And my data, you have to provide data to. Data is equal to df. My data name is equal to df. And that's it. So this is my first visualization. So I'm not able to understand anything inside this. I'm not able to understand anything inside this. So this is like a very random. It's just a line. So what I'm gonna do, I'm gonna create something else.
Average
I'm gonna
rooms.
do, let's say, because this is a very big data, so you get to find anything meaningful inside this data is gonna be difficult by using exploration. So let's say I want to use what I want to use. I want to use
Average rooms. You will find.
I can do this. Yeah, I can do this. I'm going to show you one geospatial map too. So yeah, that would be important. So what I'm going to show you, I'm going to show you a longitude and latitude and price. So yeah, yeah, that would make sense. Let me show you. Let me think how I can make that graph. I can use scatter plot. Yeah, I can use scatter plot. So this is, guys, multivariate graph. I can use scatter plot. And what I'm going to do, I'm going to use x is equal to, I'm going to use x as my longitude. So this graph going to be interesting, guys. Longitude. And I'm going to use y as my latitude. X as a longitude, y as a latitude. It should be in quotes. Then I'm going to use price as my color distribution. Yeah, I'm going to use price and hue is equal to, guys, what is hue? Hue is a color. Okay, so let me show you what is the meaning of this. I'm going to show you the graph first. Hue is the price. Okay, I need to give the data as well, I guess. Data is equal to df. Look at this, guys. Look at this. Now go to the maps, and this is the California data. Now, guys, what do you understand from this data? Any conclusion you want to make from this data? Yeah, Priyanka, you want to say something?
The dark color has high
Yeah,
density.
it's already, it's like, what is the meaning of this? Means light means less expensive, 2 means more expensive, 3 means very expensive, 4 means very, very expensive, 5 means super expensive. So from this data, what you can conclude from this graph? Guys, please, it's pretty straightforward conclusion.
More
If you move away from latitude,
No, yeah, you can say that. But if you go to the California map, so this part is the ocean, guys.
oceans,
This is the
yeah,
Pacific
yeah, yeah,
Ocean. So the houses
yeah,
which are close to which are proximity to the ocean are more
they're
expensive,
expensive.
and the houses which are away from ocean are less expensive.
Yeah.
If you go to the California map, this side is the Pacific Ocean. This is the Pacific Ocean. This is the California map.
Okay.
Okay. And if you're close to ocean, that means your houses are going to be expensive. If you are away from ocean, that means your houses are going to be less expensive. That's the first conclusion. So from this graph, I can make this conclusion. From this graph, I cannot create any conclusion. Okay. So the next, let's create one. Let's create something else. Let's create a pair plot. So there is one pair plot, guys. What is a pair plot? Let me show you. SNS dot pair plot. So inside SNS dot pair plot, I'm gonna use all the columns. So I'm gonna use some columns. Let's say df. I'm gonna use first columns. I'm gonna use is price. Second column I'm gonna use is my square footage. Price. What is the square footage or square foot? I don't have any square footage. Okay. So I don't have any square foot, right? I don't have any area here. Okay, I don't have any area here. So I'm going to use price as the first one. And the second one I'm going to use. Second one I'm going to use number of bedrooms, let's say. Number of bedrooms. Third, I'm going to use a number of like median, let's say median income. Let's say median income is also important parameter, median inc. Median inc, med inc. So this is also important parameter. I'm going to use these parameters for pair plot. Okay, what happened? Bedroom is not in excess. Okay, so that means the name is something else. Average AVE bedrooms, B bedrooms, AVE bedrooms. AVE bed RMS bedrooms. So look at this median plot, guys. Pair plot means it will create a scatter plot for all these columns. So let's see. So it's also multivariate analysis. Look at this. So it's creating a histogram for price. So majority of house lies here. Majority of house lies here. Then it's creating a plot for average bedrooms. Look at this, price and average bedrooms, price and average bedrooms. So majority of houses has 1 bedroom. Now look at this. Then it's creating a plot for price and median income. So price and median income. So price and median income is quite linear. When price is so on x-axis we have median income, on y-axis we have price. When median income is increasing, price is also increasing. Okay, it's not a very linear relationship, but it's quite linear. Okay, guys. So this is not very useful, but it's somewhat useful. So this graph is somewhat useful. This graph is somewhat useful. So from this graph, you get to know that. So if I want to create this graph, let's say, let me show this graph. So SNS dot hist SNS dot histogram. Let me check the syntax for histogram. SNS dot hist plot, SNS dot hist plot, and here I'm going to give df price, and I'm going to give bins. Guys, you know what is histogram? Like, you have made this graph so many times in your grade 10 or 11. Bins is equal to, let's say, 30 KD, KDE is equal to true. So I'm using different parameters here. Okay, KD, okay, the two. This is called histogram, guys. So from this graph, you get to know that majority of the houses are in between 1 to 2. 1 to 2 means 100,000 to 200,000. Majority of the houses are in between 100,000 to $200,000. And look at this, there is a one upward thing here. Maybe probably this is the Los Angeles, because in Los Angeles every house is expensive. So that's why all the houses are more than 5. Or San Francisco, I don't know which city is this. Probably in this particular area, all the houses are expensive. Okay, so this graph is called, guys, univariate analysis. Why univariate? Because I'm only analyzing one column. So this is univariate. This is, if you talk about one graph, this is a bivariate. If you talk about all the graph, this is multivariate. This is also multivariate. Why multivariate? I'm using 1 column, 2 column, 3 column. Okay, this graph is bivariate. I'm using only 2 columns. Okay, guys. Guys, any questions? So when to make what? It's a practice. Yeah, go ahead.
U keyword is HUE keyword is used to
Color
find
combination.
color.
Yeah. So I'm using price column as a color. So look at this. So inside this we have a different price columns. 1, 2, 3, 4, 5. So for 1 it's a light color. For 2 it's a bit dark. 3 very dark. 4 very very dark, and 5 most dark. So that's why I'm giving price as a color combination. Usually we use hue and size. There is one more thing called size. And size means it will also give you, let's say size is equal to, I'm going to say size is equal to let's say size is equal to let's use another column. Size is equal to average occupancy. Let's say average occupancy. So average occupancy. So size, it will change the size as well. Size means the size of the circle. Look at this. So where average occupancy is 250, that is a smaller one. where average occupancy is very big, 1,000, that is a bigger one. So whichever the biggest circle where occupancy is high, that is a dark one. Okay. You can also use size. Usually we use hue, size for category data, but in this data set we don't have any category data. All the columns are continuous columns. All the columns are numerical data. We don't have any category data, so that's why it's not recommended to use hue and size for numerical data. Okay, but it's case study to case study. Any other questions, guys? I know
How to read this
it's a
pair
lot.
plot?
Say again.
How to read this pair plot
This
visualization?
one. Okay.
Yeah.
So look at this pair plot. So look at this on y-axis. First of all, let's look at y-axis. Y-axis. Let's talk about price first. So price with price, I'm comparing price with price. So that's why I'm creating a univariate graph. So it's a histogram graph. It's a univariate graph because I'm comparing one column with same column. So that's why it's creating univariate graph. So histogram is a univariate graph. This one is clear, Deep, or not?
Yeah,
First one.
yeah.
Second one. Now his price is a continuous data. Average bedroom is also continuous data. So this is x-axis on x-axis average bedroom. So I'm comparing this graph and price. This is a scatter plot. So what is pair plot? Inside pair plot, you can create multiple plots at one time. So you can use multiple columns at one time. So you don't have to create one graph for two columns, to another graph for another graph for another two columns. Inside pair plot, you can create all the graphs for all the columns. So that is the advantage of pair plot.
So in the first one, price, the second one you say, just show scatter plot. So that one has like price against average bedrooms, right?
Yeah.
Okay. So
then
we
third
are
one,
comparing
price against median income.
Median income, yes. Okay.
In this one, average bedroom against price.
Price. Okay.
In this one,
So
average bedroom against average bedroom.
Average bedroom, yeah.
In this one, average bedroom against median income.
Median income, okay.
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 Okay, guys. So there are now which graph you have to make. It's a task. Okay. You have to do a lot of visualizations. You have to create a lot of visualizations to understand the data. Okay. I can create as many graphs I want. I can create box plot as well. Guys, you know what is box plot? Guys, you know what is box plot?
Nope.
Okay, so it's also very important graph. We use box plot to find outliers in data set. Now, what is box plot? What is outliers? I'm going to explain it some other time. If we have any data science class, then I'm going to explain that during that time. Okay. So box plot, why we use box plot? We use box plot to find outliers in your data. Sometimes there are some outliers in your data. You want to find those outliers. So for that, we need box plot graph. Okay. So guys, that's it for visualization. I don't want to stretch more on visualization. Any questions regarding visualization? So I want to move further after that.
I don't have any particular question, but if we need to save these graphs, how we can save?
Save, okay. It's very easy.
Yeah.
Okay, so let me remind the syntax. It's I think df.to save. PLT to do. Let me check the syntax. It's a PLT to save. Let me check. Okay, if I want to save this graph, so what I have to do? Plot PLT dot save, something like that. Save fig, I guess. So I can save this graph. No, something else. I need to give the name as well. So let's say I want to say histogram for price, and I need to give the syntax as well, .png. Okay, So let's do it again. Now my plot is saved. You can go here. Now you look at this. Your graph is saved here. Now you can download. You can take this and you can download this graph. I came out of the disk. Just give me 1 second, guys. Where I am been.
It worked.
Yeah, it worked, but I need to go outside first.
It's gonna be, I think, under user
I don't know like which directory I was using.
USR. Yeah, I think it's gonna be somewhere in there.
I think it's not inside this. I think it's inside collab. Okay, guys, so it's gonna work like this. So let's say this is my plot. I need to give this plot.savefig. If I run this, okay, my file should be somewhere here. I'm out of directory now. I don't remember how to go back. I think it's inside this Python. Thanks. Yeah, this one. So this is my PPA histogram for price.png content, and I can download this one from here. Okay, guys, I can download this graph here. Now your file is here. Now you can open file. Now your graph is downloaded here. Okay, guys. So guys, let's move to the next part now.
I have a question for
Yeah, go ahead.
this histogram. When we write a syntax to create it, we define just one column, we pass one column as a parameter. And what is this bins and KD used for?
Bin size is a bin size, like how many bins I want to create, how many these plots I want to create, like 1, 2. Right now I have given 30, right? So it's going to create 30. If you give like only 20, let's say. So it's going to smaller the bin size. Bin size is a bucket size. So it's going to like these bars, it's going to, now it's 20 bars. Before it was 30 bars. Okay.
Yeah.
And KD is like this plot, this line. So in histogram, we are connecting with middle point of all the plots. So from this middle point, 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 middle point. So it's using middle point of each plot. So it's a KD. If you don't want, you can make it false, or you remove this, it will still work without the line. But KD will show you like how this graph is behaving. From like here it's moving upward side, and here it's moving downward side, and here it's again moving upward side. So it's showing you the trend of your data set. Okay.
Yeah.
Okay, guys. So let's move to the next part. Next part is now how to analyze this data set, like how to predict this data set for future unknowns. So that is the machine learning part. Most of the part we haven't covered, because like before using it, I should explain it each and every point, but I haven't explained that before doing that. So I'm going to show you how we can do that. Okay. If you have any questions, please ask it. So my visualization is done. I want to show you one more visualization that is also very important. I haven't shown you that. That one is like a correlation. Guys, you know what is correlation? Guys, everybody knows what is correlation, right?
Yes, but I forgot.
Yeah, correlation between like correlation is meaning
like the relationship between each column. So so there is a, I can do like this, SNS dot heat map. So SNS dot heat map, I'm going to use this correlation. So I'm going to say df data is equal to df dot core. Let me use this. And I'm going to, and not is equal to true. And style is equal to, there is, then there is style. I want to show you particular style. Okay, this graph is very small. I want to make it bigger. So I want to say plot dot figure fig size. So how to increase the size of the graph? Like by this, I can increase the size of the graph. 15,6. So this is how I can make a bigger graph. Okay. Now this color combination is not very good. I want to change the color combination too. So I'm going to use, so this is the color combination. C map is equal to cool, warm, cool, warm. So this is better. Now guys, look at this relationship now. So from this you get to know, the relationship between each and every variable. Look, you get to know, look at the relationship between average rooms and price, 0.33. Okay, look at the relationship between price and median income. Price and median income is strong. So anything close to 1 or -1 is a strong relationship. Anything close to 0 is a weak relationship. Anything close to 1 is a strong relationship. Anything close to 0 is weak relationship. Sign can be anything, positive or negative. If the sign is positive, that means positive relationship. If sign is negative, that means negative relationship. So guys, what is the meaning of positive relationship? If one thing is increasing, another thing is also increasing. If median income is increasing, price is also increasing. This is a positive relationship. Okay. What is the negative relationship? If latitude is increasing, longitude is decreasing. That is a negative relationship. If latitude is increasing, longitude is decreasing.
Inversely proportional.
Yeah. Minus means inversely proportional. Plus means directly proportional. Or if it's close to 1, strong relationship. Close to 0, weak relationship. So this is also important. Okay, correlation. So by doing this, I'm getting correlation for each column, for all the columns. For all the columns, the relationship between each other. So look at this. This is the relationship between median income with all the columns. In first row, the relationship between median income with all the columns. Then in second row, the relationship with house age with all the columns. Third row, the relationship with average rooms with all the columns. So guys, I hope you are able to understand this. Let me give you this. This is also very important visualization. You can also make it on your system. Okay, guys, so this part is clear. Any questions anybody wants to ask? Guys, any questions anybody wants to ask? Guys, say something.
No questions.
Okay. So guys, the next part we want to cover is how to train the model. Now, things are going to be a bit complicated here. How to train the model. Okay, how to train the model. So this is like bit difficult to understand because we haven't covered so many parts, but I'm going to try my best to explain you each and every point. Okay, guys. So first of all, what I'm going to do, So in any model training, whenever we create any model for insurance company, for price estimation, real estate company, for any company which estimates something based on input data. First of all, we do what we do. We divide. Let me show you. We divide data set into two parts: training data set and test data set. Training data set we're going to use to check whether, like, to understand. Training data set is like a lectures. Training data set is like a lectures in the class, and test data set is like an exam. So what are we going to do? We're going to divide the data set into two parts: training and test. We divide the data set into two parts: training and test. With the training data, I'm going to train my model with the training data. I'm going to, like, model is like a human being. Model is like a student. Right now, student doesn't know anything. Model is like a student. Student doesn't know anything. Student haven't attended any classes. Student haven't attended any exam. Student is blank right now. So student's going to learn by taking lectures. Student gonna learn by taking lectures. Student gonna learn by using training data. Okay. First of all, how to divide the data set into two parts? We gotta divide the data set into two parts: training and test. How we can do that? Let me show you. So now the next step is model training. Model training. So in the training model, first step one is divide the data set into two parts. Okay. Divide the data set into parts. So in this data set, two parts. In this data set, how I'm going to add, there is a library called inside sklearn, there is a library called train test split from sklearn. This is a library called sklearn. By using this library, I'm going to do model selection first. sklearn.model selection library. Inside this library, there is a method called import train test split. So what this method does, this method convert the data into two parts. By using this method convert the data into two parts. Okay. So how I'm going to convert the data into two parts? I'm going to convert the data into two parts. So, okay. First of all, before doing that, I want to show you one more thing. I forgot to show you that. First, I'm going to convert this data set. Now look at this DF. Let's open this DF first. Inside this DF, we have input features and output features. So these all are my input features. And this is my output variable. I want to predict this. This is my output variable. Okay. So what I'm going to do, I'm going to divide the data into two parts. First one is I'm going to divide it into independent features and output variables separately. Okay. First of all, I'm going to divide this data into two parts. How I'm going to do that? Before doing the splitting, first I'm going to divide the data into two parts. First, I'm going to divide the data into X and Y. X is equal to df, and I'm going to say df dot drop. I want to drop last column, right? I don't want output variable. I don't want output variable in my data set. I'm going to drop that column. df dot drop price. I want to drop this column. So this is okay. X is equal to df dot price is X is equal to 1, I guess, because I'm not mentioning X is equal to 1. Now this is my now my X now inside. Now if I open X now, if I open X now look at this X. Now in this price has dropped. Price has dropped. Okay, there is no more price now. So X from X I'm dropping price. Then I want to inside Y I only want price column. Inside Y I only want price column. So these are my X and Y, guys. So if you look at X now, X is this. And if you look at Y now, Y is this. So Y is only price column and X is only all the input features. Okay, X is all the input features and Y is only price column. Okay, guys, any questions here? Any questions here, guys? Guys, say yes or no, please.
No.
Okay. Now my X and Y are divided. Why I'm doing that? I want to show you why I'm doing that. So I want to use this train test split. What I'm going to do, I'm going to divide my data set into two parts: train data and test data. Train data is like lectures, test data is like exam. From the whole syllabus means data set. From the whole syllabus, I'm gonna cover the syllabus by giving lectures. Then I'm gonna test the model by taking an exam. Okay, so similarly, what I'm going to do, I'm going to divide the data set in two parts. X train. Now, X variable has input features. X variable has input features. So first, I'm going to divide X into two parts, train and test. X train, X test. X train and X test. Then I'm going to divide the Y feature in two parts, Y train and Y test. Okay, I'm going to divide the X and Y into two parts, X train, X test, Y train, Y test. So then I'm going to use this library. Train test split. And inside this, I'm going to give X comma Y. So the whole X will divide into parts, train and test. Whole Y will divide into parts, train and test. Guys, do you understand this concept or not?
Yes.
Then what I'm going to do after that, I'm going to do I'm going to divide this data randomly. Okay, I'm going to divide this data randomly. So it's up to you. You can divide randomly, or you can divide like first 75% go to the training data set and next 25 will go to the test data set. But we do it randomly, random state. So you can give any number here. Random state. You can give any number here. So random state is equal to, let's say, 42. You can give any number here, 0, 1, 2, 100. There is no limit. You can give any number here. And here, there is one more parameter I have to give, test size. Test size. So test size should be what? Test size means, guys, what percent of data will go to the test? From the whole data set, what percent of data will go to the test size? So if I say 0.30, so 30% of data will go to the test size. So usually we give from 20 to 35% data. Usually for the test size, we use 20 to 35% data. It's up to you. Between 20 to 35% data, you can use any test size. Okay. So this is how I'm going to divide my data. So inside training data, now 70% of data will go to the train and 30% of data will go to the test. From the whole data set, 70% will go to the train and 30% go to the test. Now it's clear. Now it's divided. X train dot shape, Y train, X test dot shape, train dot shape, test dot shape. Look at this, guys. So look at this. So X train is a two-dimensional data. Two-dimensional data. Why? Because there are like 8 columns and 14,448 records. In X test is also two-dimensional data. 6,182 records and 8 columns. Y train is a one-dimensional data. 14,488 records, but only 1 column. So that's why it's not displaying here. And Y test is also one-dimensional data. 6,182 records and 1 column here. That's why it's not mentioning here. Okay, guys, do you understand this or not? If you add 14,488 with 6,192, it will give you 20,648. 20,640. It will give you this number. Okay, guys.
What does random state 42 represent?
Random means randomly divide the data. Let's suppose we have this 20,000 records now. So randomly, like this 0 will go to the test train. This 1 will go to the train. This 2 will go to the test. This 3 will go to the test. This 4 will go to the test. 5,
Yeah,
6, 7 will go to the train. So randomly, my data will go to the train and test.
Yeah, but what is 42 there?
42, it's any number. It's a seed. It's a seed
okay.
we are giving. You can give 0, 1, 2, 3, any number you can give. If I give 1, so my random division is something else. If I give 2, my random division is something else. Why we are giving 42 or why we are giving any particular number? Suppose if you are giving 42 and I am giving 42, the data will divide in the same way. Your 42, if you give 42 random number, suppose let me give an example here. Let's say this is my data first. This is name. This is score. These are the 2 columns. Name A will have 90. B will have 95. C will have 105. D will have 110. E will have 100. So suppose this is my data set. Now if I say like let's say out of 5, 20% data will go to. So what is the 20% of 5? 20% of 5 is 1. 20% of 5 is 1. So 1 data will go to the test and 4 data will go for 1 record will go to the test and 4 records will go to the train. If you give random state is equal to 1. So 1 means, let's suppose this data is going to my test. This data is going to the test and all other data is going to the train. Suppose if your random state is equal to 100, suppose your random state is equal to 100. Suppose your random state is going to equal to 100. Let's suppose this data is going to my test. This data is my test and all other data A, B, C and E are my train. So whenever you're going to use random state 100, every time D will go to the test and all other will go to the train. Every time you use random state 1, A will go to the test and B, C, D, E will go to the train. So random state means it will make sure every time you give this number, your data will split in the same way. Do you understand what I'm trying to say here?
Yes, got it.
So number means you can give any number, but whenever you're going to use 42, so suppose today's date, 5th November, I'm using 42. So right now my data will split in certain way. Tomorrow, if I'm going to use the same number, my data will split again in the same way. It will not split in some other way. So random state means it will make sure that your data will split in the same way every time if you're using the same data set. That is the only way if you don't give any random state number, it will split automatically. It's an optional parameter. Right now, don't think about too much about this parameter. Okay. So guys, now this is my X-train X-test. Now I'm going to use model. Now I'm going to use model training. So how I'm going to use model training here? So from sklearn, dot linear model. So this is the one of the model. There are so many models inside machine learning. This is the one of model. And inside this model, I'm going to use regression model. Import. This is the most common model, linear regression. What is linear regression? That's another time. Linear regression model. Linear regression means in simpler way, all the input features have a linear relationship with the output features. My output variable is dependent linearly on my input features. My output, let's suppose my output variable is this. What is my output variable here, guys? My output variable is
Price.
Just let me write it. So what is the linear regression means? My output variable is price. My price is dependent on, let's suppose I'm giving a hypothetical example. My price is dependent on 0.5 times median income minus 1.1 times longitude plus 1.2 times latitude minus 0.97 times average bedroom plus 1.1 times average bathroom, whatever the parameters we have in this, plus 3 times house age. So linear relationship, like look at this, there is a linear relationship, price and this, price and longitude, price and average bedroom, price and average bathroom, linearly dependent. So that is called linear regression. Okay, guys. So if there is a linearly dependency between output variable and input variable, then we use linear regression model. Why we are using linear regression, why we are not using any other model, that's another task. When we're going to start machine learning, then we're going to discuss that. But linear regression is the most common one. This is the foundational model. Okay, this is the most common model. Okay, so linear regression means output variable is dependent on input variables linearly. Linear means 1 degree, not quadratic, not 2 degree here. My output variable is not dependent on median income square. It's not square here because linear means linear relationship. It's not a quadratic curve relationship. It's not non-linear. It's a linear. Linear means direct relationship, single degree. Okay, guys, I hope it's clear. Guys, that's clear. What I'm trying to say is, guys, do you understand what is linear regression?
Yes.
Linear regression means my output variable is dependent on my input variables linearly. That's it. Now, first of all, this is my model now. This is my model. Okay, I'm going to run this model. I'm going to say reg is equal to, I'm going to use shorter name. You can use any name you want. I'm going to say linear regression because I want to use this name again and again. So this is my shorter name. Then I'm going to train my data. I'm going to training my data inside this model. So reg dot fit. So fit means train my data. So by training data, so X train and Y train, these are the lectures. I'm inside my lectures, I'm giving my lectures and I'm also giving my solutions. So Y train are my input features and X train are my input features and Y train are my solution for those features. I'm giving inside my training, I'm giving both lectures, input features as well as solution for those features. I'm giving both. So my model is trained now. My model is trained now. Inside this, my model is trained. Okay, my model is trained by using X train and Y train. Now I want to test this data. I want to test this data. How I'm going to test this data? There is a way to test this data. Y pred. Like I'm using this variable Y pred. I want to predict Y value. And I want to use reg dot predict. I want to use reg dot predict. And here I'm only going to ask questions. I'm only going to ask questions. Inside this, I'm only going to ask questions. I'm only going to give test data. What is my test data? I'm only giving here test data. Look at this. I'm not giving solution for test data. I'm not giving solution for test data. Solution for test data is Y test. I'm only giving input features for test data. and I want to predict values for this data, because from here my model has trained, my model has learned from training data. Now based on this data, my model will predict from the unknown data. This is my unknown data, because the solution for this data is not provided to my model. The solution for this data is not provided to my model. Okay, so from here I'm going to predict some value. So this is my predicted value. These are my predicted value. Now I'm going to check the accuracy of my model. My model has predicted now. I want to check the accuracy of my model. How I'm going to check the accuracy of model? The one way is from sklearn dot metrics, import. So this is the check the performance, check the accuracy of the model. Import R2 score. Now what is R2 score? I'm going to explain it some other time. What is R2 score? R2 score is a accuracy model. It will check how many values are predicted accurately. Okay, so this is R2 score. So I'm going to say R2 underscore score, and here I'm going to give my predicted values. My predicted values is, what is my predicted value? This is my predicted values. Here I'm going to give my predicted values, and these are my actual values. So I'm comparing my predicted values with my actual values. Okay, I'm comparing my predicted values with my actual values, and I'm going to calculate. So this is my accuracy score. So my accuracy score is 0.34. It's very low. My accuracy score is 0.34. So if it's closer to 1, then it's highly accurate. If it's away from 1, then it's less accurate. Okay, closer to 1, highly accurate. Away from 1 is less accurate. Okay, now one more thing I want to show you. Actual values. Look at this. Y pred. What is Y pred here? So these are my Y pred here. If this is Y pred, let me show you the Y test. So these are the actual values. These are predicted values. Look at this. Actually, for this record, actual value was 0.477, but my model has predicted 0.72. So lot of error. For this value, actual value was 0.458, and my model is predicted 1.76. Very less accurate value. For this, actual value was 5.00, and my model is predicted 2.7 something. Lot of error. So how to calculate error? To calculate the average error between all the values. There is mean squared error, MSE, mean squared error. To calculate the average error between predicted and actual values. How to calculate the this? So there is function called mean squared error. So mean squared error, what mean squared error will do? It will compare the actual minus predicted mean. So mean, look at this. So mean squared error is $53,000. $56 is the mean squared error. Suppose actual value. So according to this model, so what is the meaning of this value? Actual value, suppose actual value is let's say $500,000. Suppose this is my actual value. My model will predict between $447,000 to $53,000. So my model will predict in between this value. Suppose your cost of your house is $500,000, but if you give input features, my model will predict between this range. It can be on either side. Okay, so that is the accuracy of my model. So this is the mean squared error. Guys, any questions now? Let me revise everything. First of all, any questions before revision? Guys, any questions?
No.
Okay, no questions at all, guys. Everybody understood everything? Okay.
If this model does not work, it means we need to try some other one, not linear regression. There is no.
Again?
Because we have seen, okay, there is very less relation between input and output here.
Yeah.
So it means there is no linear regression, linear
No,
relation.
probably linear regression model is not good for this kind of problem. Probably some other model is good
Some
for this
other
kind of
model.
problem.
Okay.
So because when we find solution, when we create a model, we use lot of models. We cannot use only one model and deploy that model. We're going to use lot of models. So once, like, suppose if with model M1 my accuracy is this, with M2 my accuracy is this, with M3 my accuracy is this. Whichever model has highest accuracy, I'm going to use that model for my prediction. Okay, Mehak.
Yeah, got it.
Now guys, let me revise everything first of all. I know this is a bit a task, but this is how we do case studies. I just want to show you case studies, how we use Python for the case studies. So first of all, we're going to import some library. Then we're going to use any data set. It can be any data set. Sometimes we're going to load from local machine. Sometimes we're going to load from some online source. Okay. There are so many ways we can load the data inside pandas. Okay. Once your data is loaded, the first step is to clean the data set. First step is to clean the data set. How to clean the data set depends on what kind of problem we have in the data set. Sometimes we have missing values. Sometimes we have some different data types. Suppose we have this appear as a numerical data type, but actually it's a string data type. Sometimes we need to convert the data type too. So there are so many problems of data cleaning. Okay, so it can be anything. So we need to find the different problems in data cleaning. So once your data is clean, then you do data exploration. So we spend a lot of time on data exploration to understand what is my data, which features are important for my data. Because from visualization, I can conclude in a better way in comparison to numbers. Because from numbers, you cannot understand anything. But from visualization, you can understand the relationship. So once you understood the relationship by visualization, then you divide the data set into two parts, X and Y. X is your input feature and Y is your output feature. X is your input features, Y is your output features. Once this part is done, then you divide the data into two parts, training and test. Training is like a lectures, you provide lectures, and test is like an exam. Okay, test is like an exam. And inside the test, you separate the solutions from somewhere else. Okay, so once your model is trained with training data, then you take the exam from your training data. You take the exam from your model. How you going to take the exam from model? By only asking questions. So X test is only asking questions. You are not providing solution for X test. Once model will give you answers for X test, once your model will give you answer for X test, then you compare model answers and actual answers by using different metrics. One metric is R2 score. R2 score means if your R2 score is closer to 1, highly accurate. If it's closer to 0, then very less accurate. So R2 score is in between 0 to 1. R2 score is accuracy score. Just in shorter word, there is a formula for R2 score. You can check online. Okay. And then mean squared error. Mean squared error is difference between actual and predicted value. Difference between actual and predicted value. Okay, for all the recordings, difference between actual and predicted values and mean of those values. That is the mean squared error. If your mean squared error is less, then your model is accurate. If your mean squared error is more, then your model is less accurate. So this is how we achieve case study. Any questions, guys? Anybody wants to ask?
Yes. Then we divide the data into as input and output. Then we
Yeah.
divide that into the train and test. So basically, are we dividing the input data into train or test like that?
No, both. Look at this. First,
yeah.
X. Look at this here. X and Y. So X train and test we use for X data. Y train and test we use for Y data. So look at this. Let's suppose this is my date record. Look at this particular record. So first of all, I'm going to divide this as x. Suppose this is x1. Let's suppose this is x0. The whole record is the x0. So x0 is this 8.3 to 8.3252, 4.41.0, 6.98, 1.02, 322, 2.55, 37.88, minus 1.2, 122.23, and y naught is 4.526. Okay. Now similarly, you can say x1 is next one is this. This is my x1 and this is my y1. This is my x2 and this is my y2. Okay. Now we have from x1 to x 20,640. Similarly, from y1 we have y1 up to y 20,640. Right? From x1 to 20,640, x y1 to y 20,640. So this x1 to 20,640 will divide into two parts: x train and x test. Similarly, this y1 will divide into two parts: y train and y test. Is it clear or not? Priyanka, is that you? Is it clear to you?
Yeah.
So this is how we do that. Okay. Okay, guys. Thank you so much. Have a great week and enjoy your weekend. And any questions you have, any questions you want to ask in future, you can ask anytime. Okay, guys. Thank you so much.
Thank you.
Thank you, guys. Bye bye. Have a great week.
Thank you.
Thank you.